Let me record a class in case I forget later. We have 2 sections in this class. The first section, 903. Is Riz here?
I'm here.
Thank you. Jackson? Jack is here. Jackson. Let me see the last name. Jackson is not here. Jessica? Molly? Jessica is here. Sorry. Yeah, Jessica and Molly both are here. Cindy. Cindy is not here. So we're missing 2 students from this section. Okay. Let me save this. And the second section, 904. Emerson. Emerson is not here. Alex. Alex is here. Awesome. Lexi. Thank you. Thank you, Lexi. Emma. Do we have 2 Emma? Just the 1. Yeah, just the Emma. Thank you. Emma is here. Ashley is here. Jack is here. Angie. Angie is not here. Jennifer. Jennifer is not here. Crystal is here. Charlie is here. But Cindy is here. Did I miss you? Did you just join us? Oh, okay, give me a little bit of time to fix it. Crystal's here, Charlie's here, Chloe's not here. Levi is here. Very good. So we have 8 presents. The other section is 4, 12. So we're missing Emerson, Angie, Jennifer, Chloe. Today.
Can you hear me? I am here, Miss Betty.
Yeah, Angie.
Okay, can you hear me? I'm trying to get all my stuff set up. I can't see y'all. But I am here.
Okay, awesome.
All right.
Let me fix it. It's Angie, okay. Right?
Yes, Angie Prince Edwards. Yes, ma'am.
Yeah. Okay, awesome. Yeah, I remember your voice.
Yeah, I've told it's pretty loud.
No, I didn't mean that. I like your voice.
I know.
Okay, very good. Thanks for coming. Thanks for coming. So today we are going to start chapter 2. You guys see my note, right? Just want to make sure.
I can't see anything, Miss Betty. I can't see nothing. Is you showing something? Why I can't see?
Okay, let's fix that. Yeah, they can see. You're supposed to see my notes because now I'm sharing my notes. Like chapter 2.1, basic set concepts. You should be able to see that. All right? Ready to get started? So today we are going to start chapter 2. Chapter 2 is about the set theory. Our syllabus scheduled today to cover the first 2 sections of chapter 2. The first section is about some basics about sets. Let's give the definition for sets first. A set is a collection of objects excuse me, and the objects are called the elements of the set. A group of members. The group or collection is the set. The members in the set are elements. We use capital letters such as A, B, C, and so on to represent the sets. And we use lowercase letters A, B, C, or D, and so on to represent elements of a set. Those are the notations for sets and the elements of a set. Let's say we have a set A. One way to present set A is to list its elements one by one, like this, and use commas to separate those elements, and use a braces to frame those elements. This is to show set A contains 3 elements. The 3 elements are A, B, and C. Knowing this is a brace, a set of braces, not parentheses. We do not use parentheses to represent a set. We do not use bracket either. The notation for sets are braces. And we can say A is in set A. This notation, like a semicircle, and in the middle we have a short bar. This notation means belong to. If we have the same notation, but you draw a slash across the notation, and that means not belong to. For a well-defined set, we are able to determine if a specific element belongs to a set or not. For example, set A has 3 elements, A, B, C, right? Then we can say element A is in set A. We can use this notation, A belongs to A, to demonstrate the fact. Since element D is not in set A, it does not belong to A, right? We can write element D does not belong to A, or element D is not in set A. So for any element and any set, one of the 2 notations, one or the other, would connect the 2 things. Either the element is in the set, or the element is not in the set, right? Any questions? That's just a notation. In order, excuse me. Thank you, Ashlyn. Do we have more people join us? Just let you know, just remember, if you missed the roll calling, please remember to email me, and I can fix your attendance. All right. Let's continue. Ace, in order, I'm sorry. I couldn't hear. Does anybody want to say anything? Okay, a set must be well defined. Not any collection or group of objects can be called as a set. A set must be well defined. Otherwise, there's no meaning. A well-defined set requires the elements are clearly determined. The elements in the set must be clearly determined. Otherwise, the set is not well defined. We cannot say that collection as a set. Let me give you some examples to explain. Let's consider this set. Set B is the set of all older students at the TCC. All right, look at this example. Consider this set. Set B is a set of all older students of our college. Determine if this set B, well defined. Are you looking at a set well defined or not? Consider if the elements in the set clearly determined. What do you think? Older students. How old is older students? 19 is older or 40 is older? Is the elements clearly determined? Not really, right? Yeah, I believe you see it. Perfect. Thank you for your response. This set is not well defined. As you can see, the elements are not clear. What's the criteria for older students, right? So this is not a well-defined set. Another example, let's say set C is the set of all the rich people living in Tulsa area. Let's consider this collection of objects. Let's consider this set. Set C is the set of all the rich people living in Tulsa area. Is this set well defined? Are the elements in set C clearly determined? All the rich people. What do you think? Maybe ask yourself, am I belong to this set, right? If you live in Tulsa area. I don't live in Tulsa area, so I definitely is not in a set. You're right. This set is not well defined either because the elements are not clearly determined. Rich people, how rich is rich, right? We don't have a criteria to make a decision about a certain element belong to or not belong to the set, right? So this is another example. The set is not well defined because the elements are not clearly determined. Let's consider set D. Set D is the set of even natural numbers less than 10. Excuse me. Consider this D. Consider this set D. Set D is the set of even natural numbers less than 10. Is this set well defined? Consider, are the elements in the set clearly determined? What are the elements in the set? Are we able to make a decision about a specific number belong to or not belong to that set? Yes, exactly. This is a well-defined set, all right? If we write out all the elements in the set, let's see what elements belong to the set. Does 0 belong to the set? Let's consider even natural numbers less than 10. We understand what is even number, right? Even odd is about integers. If the integer is divisible by 2, the integer is even. Otherwise, the integer is odd. So even numbers include a 0. Some people probably don't remember 0 is also an even number. So 0 is an even number. Positive, negative 2, positive, negative 4, positive, negative 6, and so on. Those are even numbers, right? Other numbers include positive, negative 1, positive, negative 3, positive, negative 5, and so on. Those are other numbers. So here, the elements in set D are even numbers, but natural numbers. Natural numbers are all positive, so we do not consider negative even numbers. We do not consider 0 either, because 0 is not a natural number. All right, it has to be positive. And also the number has to be less than 10. Okay. Does 2 belong to the set? Is 2 in the set? Even number. 2 is the smallest even natural number, right? So 2 should be in the set. And also less than 10. Very good. What about 4? What about 6? What about 8? What about 10, guys? Is 10 in a set? D is the set of all the even natural numbers less than 10. Is 10 an element? You're right. No, because less than means strictly less than. 10 is not included. All right. So 8 is the biggest element in the set. We do not need a comma. We do not need a comma behind the last element. Okay, we do not need that. The commas are used to separate the elements. Okay, so this set contains all the even natural numbers less than 10. It is well defined because we are able to determine, make a decision on a specific element, knowing if the element in the set or not in the set. Very good. We have 3 different ways to present a set. Three different ways or 3 methods. The 3 ways to present sets. They are word description, second method is called a raster form. The third method is called a set builder notation. The first method is called a word description. If we look at this example we had earlier, set D is the set of even natural numbers less than 10. That's the method of word description. That's how do we use an English sentence to describe a set. That would be an example for the method of word description to describe a set. Set D is the set of even natural numbers less than 10, right? And the raster form means you list all the elements in the set one after another, and then use a set of braces to free them. Our example D is in the raster form. D right here, I'm talking about the green one. Yeah. This is raster form. Use a set of braces and a list of the elements in the braces. So that is a raster form. Earlier when I called the row, you can see all your guys' names one after another, right? So something like that. You just display all the elements in the set. That is a raster method. The third method is called the set builder notation. This notation is very popular in mathematics, but it's a little bit different from the other two methods. Let me give you the example. How do we use the set builder notation to present a set? We can take D as example as well. So set builder notation always follow this pattern. What pattern? Firstly, it uses a set of braces. Secondly, it always starts from X and then slash. In our note or book, they use a short vertical bar. I don't use that for a reason, because in chapter 11, we have something similar. That's supposed to be a vertical bar. And here we should use a slash. Behind a slash, that's the condition. The elements in D satisfy. So that's the criteria one can follow to determine if an element belongs to a set or not. The condition X satisfies. So here, our set D contains all the even natural numbers less than 10, right? So we can write that set in the form of set builder notation. X slash X is an even natural number that's less than 10. Means anything that satisfies the condition behind the slash is qualified to be an element in the set. If the condition is not met, if an object does not satisfy the condition behind the slash, then that object is not an element of the set. All right. So other example I can give you, for example, D. I need more space here. Let me try to insert more blank pages. All right. So let's look at E. I'm going to give you set E using the set builder notation. E is a set that contains all the elements, and those elements satisfy the condition X is a real number and X is less than 1 or greater than 5 or greater than 5. It still doesn't fit. Greater than, give me 1 second. Let me move this to oh, it's a bad idea. I'll just turn to the next line. Greater than 5. Greater than 5. Sorry. How about x is real number? Okay. By the way, this represents real number set. The fancy capital R represents the real number set. So this means x is a real number, okay? X is a real number. And also x is less than 1 or bigger or greater than 5. All right, finally. So that's set E, okay? That's the set E. I wrote E in a set builder notation. The condition that the elements of E satisfied is behind a slash. In order to be an element of set E, the element has to be a real number, and the real number has to be less than 1 or greater than 5. I'm going to highlight this logical connective or because it doesn't matter. Well, it's not very clear what elements in set E, right? The way we write it. So to make it better, let's consider drawing a real number line. Sometimes if we try to use algebra to present a concept, it might look a little bit abstract. So the approach is to bring in a graph, use the geometric tool to give you a visual assistant. So in order to explain what elements in set E, let's look at a real number line. In order to be a real number line, you might remember it needed to have a direction. So we determine to the right that's positive, to the left is negative. And it also needs to have an origin. I can put any point. I can set any point as the origin. I put an origin here, right? And the third thing is to determine how much is 1 unit. I would determine this much is 1 unit. So this is my 1, then this is my -1, right? -2, -3, -4, and so on. And then to the right, we have 2, 3, 4, 5, 6, 7, 8, 9, and so on. So the elements in set E, they are less than 1. They are real numbers, right? All the points on the real number line, they represent real numbers in the real number set. X is less than 1. 1 is right here. Or bigger than 5. So the numbers covered by the red region, those numbers are in set E. Do you agree? Do you see it, guys? Better? With this graph, you should be able to see what elements in the set, right? Real numbers less than 1 or bigger than 5. On the graph, all the real numbers that covered by the red region, they are elements in the set E. And the numbers between the two numbers, 1 and 5, including 1 and 5, those numbers do not belong to the set, right? I hope you see it with the help of the graph. Perfect. Thank you. So this is how do we use a set builder notation to describe a set. Let's look at the set F.
Can you scroll back up so I can see the right there? It's an even natural number that's less than 10.
Oh, that's set D. Yeah. X is an even natural number that less than 10. Yeah. Let me double check I'm recording. Then you can look at the. Oh yeah, I am recording class. So what about set E? Do you guys have any questions about set E? Understanding a set means you understand what elements are in a set, and you're able to determine if an object belong to the set or not belong to the set. The graph should helps you to understand that, right? All the numbers covered by the red region, in the red region, they are elements in a set. If the numbers are not in the red region, they are not in a set. Let's look at set F. I'm going to give you set F using the set builder notation as well. Okay, so we are talking about the set builder notation. We don't really use the word description too much. And the raster method is very simple. So mainly is to explain the set builder notation. Let's consider the set F. So the elements in F must be real numbers. On top of that, X is less than 1 and greater than 5. It's different, okay? Because it's not or, it's and. Only one word different. And you will see this one word different make a huge difference. Okay, what difference this make? By the way, the graph would still help you to understand. Okay, let's look at F. Can you help me to determine what elements are in the set? Can you find me an element in the set? The elements have to be real numbers and less than 1, at the same time greater than 5. We understand the logical connective and, right? Means at the same time. The elements in set F must be a real number that is less than 1 and at the same time bigger than 5. Can you help me to find some elements? What real number is less than 1 at the same time bigger than 5? I think it's just my connection. I can only hear one other word. Oh. What about other participants? Do you guys all hear me normally? Okay, perfect. And also I see 93 and 8. 93 is less than 1, but not bigger than 5. So here, I need you to help me to find a real number that is less than 1, at the same time bigger than 5. I know it's a challenging task. Chloe, I'm having trouble hearing as well. I would say maybe try to log out and then log back in to see if the connection gets better. Because if one student hears me normally, that should not be my problem, right? And also this is a pretty large class. Yeah, maybe this means the system have to carry a lot of information. That might matter. Okay. I couldn't hear either, but I caught it in on my phone for my audio and I can hear now. Okay, that's a good method. Very good.
What is going on with the screen? Okay, there you go. Thank you. Cause that was hurting my eyes. That okay.
The screen, yeah. Well, you guys have not helped me out yet. What about set F? Did you find a number, find an element in F?
I'm confused on how E and F are written the same, but asking a different question.
Yes, they are different. They are not the same. Set E can turn all the elements, can turn all the real numbers less than 1 or bigger than 5.
Okay.
Set F can turn all the real numbers less than 1 and bigger than 5.
Thank you.
It's different, two different sets. Well, did you guys help me to find an element in F? What real number less than 1 and at the same time bigger than 5? There's no such element, okay? Sorry. Is empty. F is empty. We say a set is empty or the set is an empty set if the set has no element. Yes, a set is okay to have no element. F is an empty set because there's no such number, real number, would be able to satisfy the condition behind the slash. There's no such real number less than 1 and at the same time bigger than 5, right? Do you see that? Empty set. Do you agree F is empty, guys? No. Could it be considered undefined? Oh, that's the good question. No. This set is well defined. F is well defined. Because the elements in the set are clearly determined. The standard is right here. The condition is right here. There's a way, the set gives us a way to determine if an object belongs to or not belong to the set. It is well defined. However, it is empty because there's no number satisfy the condition. Okay, thank you, Levy. That's a good question though. It is well defined, but nobody meet the criteria. You know what I'm saying? For example, if I say this set contains all the students fail the class this semester, do you want this to be empty? I mean, if by the end of the semester everybody passes the class, then the set is an empty set, right? But it is well defined. It is well defined. Okay. Empty sets are a type of special sets in set theory. So we're going to talk about empty set a little bit more, okay? They are only okay, I need to write this down. A set is an empty set if it has no element. And there are only two correct ways to denote empty set. They are either this notation or this notation. Okay, let me explain. We only have two correct ways to present an empty set. Either, this one is pretty intuitive, right? This is a set of braces. We know it represents a set, and there's nothing in it. There's nothing in it. So it represents an empty set. And the other way to represent an empty set is draw a circle and draw a slash. Yeah, because empty set is so important, we mathematicians assign a unique notation for empty sets. Those are the only two correct ways to denote empty sets. There are some other creative but incorrect ways. All right. For example, this or that or this Well, those are not empty sets. Let's see if you can see it, all right? This one is not empty. That one is not empty. That set has one element. That element is number 0, right? And this is not empty either. That set has one element as well. That element is an empty set. Yeah, this might be a little bit challenging. So when we define set, we say any collection of objects can be a set, right? The objects in the set could be anything. Could be numbers, could be pencils, could be computers, could be tables, you know, could be anything. So here could be people, right, or animals. So here, this one, I'm talking about this one. This is a set containing one element, and its element is an empty set. Yes, sets can also be elements in a set. I don't know if that confuses you or is that understandable? Anything can be an elements, right? Sets can also be an element, can be elements in a set. So this is not empty, or just you know, just try to figure out, try to understand this is not empty, right? This is not empty. This is not empty either. This set has one element. The element is a word spelling nothing. This is not even a set. It's just an English word, okay? But so they are not empty sets. And let me know, is that clear? Very important. The only two correct ways to describe, to represent empty sets are those two ways. Are we good? Okay, thank you. Thank you, Levy. Thank you, Ashlyn. Thank you, Molly. Thank you for your response. Well, okay, so let's look at this set. Can you tell me how many elements in this set? This one? How many elements? This set has one element, correct? Very good, yeah. How many elements in set F? How many elements in set F? Very good. It's empty, right? Empty sets have 0 elements. Awesome, very good. Can you tell me how many elements in set E? How many elements in set E? The elements in set E are the real numbers in the red region. Do you agree there are infinitely many elements in the set E? Yes, yes, very good, very good. Infinitely many. How many elements in set D? How many elements in set D? The green part is D. 4 elements. Very good, very good. And how many elements in set A? Right here, this is A. 3, perfect. Yeah. And you know, the number of elements in a set doesn't matter, and we have a name for it. All right. So next concept, next definition, cardinal number or cardinality. The number of elements. Okay, let's say A is a set. Okay, the number of elements in A is called the cardinality or cardinal number of A. It is denoted as n of A. Okay, n of A. So that's how do we read it. A here, capital letter A here, is a set. Little n, lowercase n here represents the cardinal number or cardinality of the set. So this notation represents the cardinal number of set A. It is the number of elements in A. Cardinal number gives us the information about how many elements in the set. It will not tell us what elements. Okay, we don't know what elements. This concept does not tell us that kind of information. It only tells us how many elements. All right, so this set has cardinal number 1, right? Because it has 1 element. And set F, the cardinal number of F is 0 because it's empty, right? Cardinal number of E is infinity. By the way, if the set has infinitely many elements, we say the set infinite. Otherwise, it's finite. And set D, the cardinal number of set D is 4 because it has 4 elements in it. And the cardinal number of A is 3 because it has 3 elements in it. All right, so I hope you remember the notation of this concept and knowing the meaning of the concept. N of A represents the cardinal number of a set A. It is the number of elements in set A. So far, so good, guys? Perfect. Thank you for your response. Okay. Next, we're going to talk about two definitions or a pair of definitions. Say A, B are 2 sets. A and B are equivalent if they have the same cardinal number. A and B are equal if the 2 sets are exactly the same. Right? So 2 definition. Let me give you an example. For example, let's say A is 1, 3, 5, 7, 9. B is 2, 4, 6, 6, 8, 10. Look at the definition. Determine are A and B equivalent? Okay. So we are trying to determine if the 2 sets A and B equivalent. You will see questions of this type in your homework assignments. You will see the same type of problem in your quizzes and the tests. Test 1, okay, the first exam covers the first 3 chapters. I guarantee you have something like that. 2 sets are equivalent. What does that mean? What qualify 2 sets to be equivalent? You need to remember, 2 sets are equivalent if they have the same cardinal numbers. All right? 2 sets are equivalent if they have the same cardinality, if the number of elements in the 2 sets are the same. Look at A and B. Are they equivalent? What is the cardinal number of A? What is the cardinal number of B? Yeah, exactly. Both of them, right? Both of them have a cardinal number 5. So they are equivalent. Do you agree, guys? They are equivalent, right? The two sets are equivalent. Yeah, equal. Hold on. Let me, because they have the same equivalent. Okay, I need a. How about let me type. Two sets are equivalent. Equivalent is different from equal, right? Equivalent. Two sets are equivalent if they have the same cardinal number. Cardinal. My set A contains 1, 3, 5, 7, 9. My set B contains 2, 4, 6, 8, 10. Yeah, those are the two sets we have. Yeah, you see it now. Perfect. The two sets are equivalent. A and B are equivalent. Because their cardinalities or cardinal number are the same. Both are 5. So based on definition, they are equivalent. However, guys, the two sets, A and B, are not equal. Okay? Equal in mathematics is very strict. To make two things equal in mathematics is very strict. The two sets have to be exactly the same. Look at A. A has elements 1, 3, 5, 7, 9. B has elements 2, 4, 6, 8, 10. None of the elements even, not even one element the same, right? They are very different. They are not equal. In order for two sets are equal, not only the two sets need to have the same number of elements, also those elements have to be exactly the same. You know what I'm saying? For example, if I give you set C, let's see if this help you to understand. If I give you C is 1 plus 1, comma 2 plus 2, comma 3 plus 3, comma 4 plus 4, comma 5 plus 5, comma. What do you think about C and B? Is it C and B equal? Huh? Even they look different, right? They do look different. But B and C are equal. Not because they both have cardinal numbers 5. B and C are equal because they have exactly the same elements. The first element in B is 2. The first element in C is 1 plus 1. 1 plus 1 is 2. The second element in B is 4. And is the same with the second element in C. 2 plus 2 is 4, right? 6, 3 plus 3 is 6, 8, 4 plus 4 is 8, 10, 5 plus 5 is 10. That's the reason B and C are equal, because they are really exactly the same. Maybe the way I write it is different, but they are actually the same thing, same elements. Please let me know, is that clear? Do you see the difference between the two concepts? Equivalent, equal. They are two different definitions. All right, yeah, one more time. For two sets to be equivalent, all it takes is they have the same cardinal numbers. But for two sets to be equal, like an equal sign, and they have to be exactly the same. Very strict. Is more than just to have the same cardinalities. Is more than that. Okay. So the last thing we need to talk about in this section is infinite set versus finite set. Pretty straightforward. A set is finite if the cardinal number of the set is a finite number. A set is infinite if the set has infinitely many elements. Okay, let me give you an example. A oh yeah. I give the two sets using the set builder notation. Okay, you need to help me to determine set A, is set A infinite or finite? And set B, is set B infinite or finite? So two examples. Let's do one at a time. Let's look at the A first. So all it matters is to find out the cardinal number of the set, right? How many elements in it? Yeah, all it takes is how many elements in it. How many elements in set A? Okay, do you understand the notation? Set builder notation, right? What elements in set A? In order to be elements in set A, they have to be okay. Oh, okay. So hold on. I need to explain what is this. This means natural number set. This is natural number set. Natural number set. You remember earlier I did this one? That is a real number set. Real number set. So set A has elements. The elements are natural numbers, and those natural numbers are no more than 2 million. No more than 2 million. So what do you think? How many elements in it? Yes, exactly. Thank you, Charlie. That's correct. Yes, actually, it's infinite. Oh, sorry, it's finite. It's finite, okay? I know 2 million is a huge, large number. Yeah, 2 million is a large number, but it is a finite set because if we use the raster method, we can also use the raster method to present the set. It is just one natural number start from 1, right? No more than 2 million. So 1, 2, 3, 4, and so on. We don't have the time to write everything, right? Just use dot 2 million. 2, 3, 1, 2, 3. So if I use the raster method to write a set, that's the set. Even if it has 2 million elements, it is finite. Even if it has trillions, even zillions elements, it is still finite. As long as it doesn't continue forever, right? To be a set that is infinite, it takes infinitely many elements. Did you guys see it, everybody? Did you guys see it? Do you guys agree number 1 is finite? Yeah. Even if it has many, but it's still finite, right? It doesn't like keep going forever. Okay, very good. And then look at number 2. Look at the set B. How many elements in set B? Set B contains all the natural numbers bigger than 800. Yeah, that's how you understand the notation. Set builder notation is very important. So set B has elements. Those elements are natural numbers bigger than 100. So if I use the raster method, I can write the elements in set B as all the natural numbers are bigger than 100. So 100 is not in the set. 101, 102, 803, 804, and so on and so on and so on, forever, right? Would you be able to see that now if we use the raster method to represent set B? Is set B finite or infinite? Yes, infinite. Okay, so please be careful. Yeah, make sure you really understand the set builder notation. Even set A can turn 2 million. It doesn't mean it is infinite. Even set B has a smaller number, 100, doesn't mean it's not infinite. It is infinite, okay? It is infinite because just continue forever, forever, forever. All right? Let me give you an example. How many elements in C, or what's the cardinal number of C? What's the cardinal number of C? Do not tell me 4, by the way. Please do not tell me 4. Oh, you guys are great. Yeah, it is 12. Okay, let me explain. How do you understand the dots here? A lot of times you can see dots, right? Because you don't really want to, sometimes you don't really want to spend the time to write really all the elements, because finite set could have many elements, time consuming to write them all, right? So you want to use a dot, dot, dot. By the way, dot, dot, dot doesn't mean 3 elements here. Does not mean 3 elements here. It depends on the set. In this example, dot, dot, dot means 4, 5, 6, 7, 8, 9, 10, and 11, right? Yeah, you can normally, they give you a few elements, just enough to show the pattern, just enough to show you what elements are in the set. And you would just make sure you understand this set does not have 4 elements. It has 12 elements, okay? It does not have 4 elements. It has more than that. Okay, very good. We have 15 minutes. We're going a little too slow. We finished section 1 now. We can go ahead to start section 2. What do we do in section 2? We talk about subset. Let me give you the definition for subset. Set A is a subset of set B, denoted as this if all elements in A are also in B. Okay, if all the elements in A are also elements in B, then we say A is a subset of B. This is a pretty important concept, subset. If all the elements in A belong to B as well, then we say A is a subset of B. This is the notation for subset, very important. It is like a U, capital U facing to the right, and there's a short bar underneath. This is a subset notation, You might not use this often, but just know you can also write this. It means the same thing. A is a subset of B, but we don't really do that. So but is correct, but we don't really use it much. Okay. Yeah, the opening facing to the set, that is a bigger set. And set A is a proper subset of set B, denoted as this. There's no bar, only a capital U facing to the right. Yeah, proper subset is different, okay? Earlier is a subset, here is a proper subset. And the notation is different either. If A is a subset of B, and there is at least one element of B is not in A. All right, it's not a lot of words. I wrote a lot of words, but it's not that complicated. It's not that complicated. I'll give you a little time to read through the concepts, the definitions. We need to memorize the two notations. With the bar, subset. This is subset. Without a bar is a proper subset. Proper subset. Okay. Let me give you an example about proper subset. Human beings. So let's say the smaller circle is a set A. It is the set of all women. Okay, all women. And the bigger one is set B, representing the set of all human beings. Okay, so set A is a proper subset of B because all the elements in A also in B, right? All the women are human beings, right? But at least one human being is not woman, because we also have males, right? We have men. So you see what I'm talking about? In order for A to be a proper subset, the smaller set is completely inside of the bigger set. Completely inside the bigger set. That is a proper subset. Proper subset. Now what happened to subset? What happened to subset? It's very similar with this. Let me give you an example about numbers. We agree 2 is less than 3, right? 2 is strictly less than 3, but it's also correct if I say 2 is no more than 3. Do you agree? 2 is no more than 3. And we know 3 equals 3. I also can write that as 3 is no more than 3. Because yes, 3 is it is no more than 3. Do you see what I'm trying to say here? So what I'm trying to say here is if A is a proper subset of B, then A is also a subset of B. If A equal to B, then A is also a subset of B. Very similar with this idea. Subset notation. Subset notation basically include two cases. It means either proper or equal. Okay, the subset notation has two cases, either proper or equal, as this means either proper, subset, or equal. One or the other, right? You see what I'm talking about? Does that make a little bit sense? Okay. Don't worry about that. If at this point it doesn't make any sense, we have some problems. Yeah, we can look at some problem together, right? Let's look at some problems together. I'm going to get the notes for 2.2. We're going to work on some problems regarding the notation, subset notation and the proper subset notation. Look at this one. In each blank, okay, write this or this in each blank such that the resulting statement is true. Firstly, let's look at this one. What should we put in the blank to make the expression a true statement? To the left of the blank, we have a set containing 3 elements, right? 94, 0, 4. And to the right, we have a set containing 1, 2, 3, 4, 5, 6 elements. Do you think this set a subset of that or not? Is this a subset of this? In order for A to be a subset of B, yeah, definition is all the elements in A must also be in B. What do you think? In other words, subset is just a part of the bigger set. It's like the women, set of women is part of the human being, right? You're right, not a subset. Perfect, you guys are great. Yeah, we should put this notation. Have a slash cross the notation means not a subset. This means not a subset, all right? You guys are great. Perfect. There's no 0. Oh yeah, you're right. There's no 0. Perfect. There's no 0 in the set on the right. 0 is not in the set on the right, right? Perfect. You guys are great. Let's look at number 2. We also have 2 sets. The 2 sets are given in the set builder notation. Sometimes when the set is given in the word description format or set builder notation, it's not really very obvious. So the best way is the raster method. But sometimes it's time consuming, but still is the best method. For this problem, is pretty not troublesome to write the 2 sets in the raster format. This set contains all the elements that is a letter in the word proof. So P, R, O, F. Some of you might wonder, you have 2 O's. Why did you only write 1 O? So this is something I need to point it out here. If a set has repeating elements, like you have 2 O's here, you don't really write the same element twice. You only write it once. O and O, that's just one element. You don't write it twice, okay? So the set on the left has 1, 2, 3, 4 elements. Let's see the set on the right. The set on the right contains all the letters in the word roof. So R-O-F. Okay, so what notation should we put between the 2 sets to make it a true statement? Is this set a subset of this one? Are we going to put this or this? Which one? Not, yeah, you're right. Not a subset. You are right. You are right. You guys are great. We should have put not a subset, right? Not a subset. This is not subset of that either. Because this says more than that, right? More elements than the one on the right. And how do we make it right? If we use this notation to connect the 2 sets, and that is correct. I mentioned this earlier, right? capital U facing to the left. That means the set on the right is a subset of the set on the left. That is okay. That is okay. All right. So what about this one? Determine whether subset notation, proper subset notation, or both of them can be placed in each blank to form a true statement. You will see something like that in your assignments. Let's look at the first one. This set, they are given in the raster method. The set on the left has element 91743. The set on the right has elements 13479. Are the two sets equal to each other? Do you guys agree the two sets are equal? Yeah, they are equal, right? Okay. In the case the two sets are equal, could we write this notation? You know, are we gonna put this notation or both? Can we use that notation to connect the two sets? Is this set a subset with itself? Similar with the idea when we say 3 is no more than 3. I agree 3 equals 3. But yes, we can still say 3 is no more than 3. Okay? If the two sets are equal to each other, they are subsets of each other. The reason we can put a subset notation here is because all the elements in this set are also in this set. The definition is satisfied. Right? Guys, do you see it? We can put this notation, but not this notation, okay? Because 3 is not strictly less than 3. That is definitely wrong. I hope you see it. Okay. Oh, sorry about that, Emma. Let's see the second one. The set, how about let me label them A and B. This way is easier to present, to refer to them. Set A on the left side is a set containing all the people who live in San Francisco. And set B contains all the people who live in California. We all know San Francisco is a city in the state of California, right? Okay, so for this problem, which one should we choose? Yeah, which one should we choose? So the answer choices here is A, we choose to put here this one. B, we choose to put this one. C is we can put both to make the expression a true statement. What do you think? Both. The correct answer is both, guys. Yeah, I see A, I see B as well. But you know the answer is supposed to be C. Sorry about that. Why? Why is that? Yeah. So do you agree? All the people who live in San Francisco also live in California, but people who live in California not necessarily living in San Francisco. They may be living in San Diego, right? So this is a proper subset for sure, right? Proper subset, but it's also a subset. Also a subset. That's why it's both. Why is both? When you have a number, when we have 2 is strictly less, if we have 2 strictly less than 3, we can also write that as 2 is no more than 3. So if A is a proper subset of B, A is also a subset of B. So that's why number 2, we should choose both. We should choose both. Please let me know, is that clear? Okay, very good. We ran out of time. So we're gonna stop here and continue talking about section 2.2 on Monday. All right, guys. Work on your math assignments. Let me know if you have any questions. Have a good weekend. I'll see you on Monday. Bye-bye.
So we're not meeting the next class?
No, I'll see you. I'll see you in central class in 10 minutes, 7
Oh,
minutes.
okay. You said next month. I'm like, oh, what the? Okay, I got you. All right.
I'm sorry. Some of you,
Yeah.
I'll see you on Monday. Others are gonna see you in 6 minutes. All right.
Yeah.
I'll see you essential every Monday, Wednesday. We have essential class at 2:30 in another class shop. I'll see you there. Bye bye.
Bye bye.